Databases. Who needs them? Well, a lot of people apparently, which is why AWS has three different options of databases for you. So we'll take a look at databases in all their glory. Well, I'll say in some of their, actually in a very little of their glory, because there's a lot you could dive into in databases, but give you an overview and then show you the three different services or offerings, I should say, that Amazon has. And then I want to talk a little bit about the AWS API. I've been mentioning it all through the series of like, oh yeah, you can API. So I want to hit that right on and say, okay, what is an API? How do I use it? How would I integrate this? All those questions right now. Let's start off with databases, and I want to take on this question from the beginning because a lot of people have it. Do I have to use Amazon's database service? Can't I run my own databases in an EC2 instance? And absolutely, you can. You can. It's your instance. You can do whatever you want. You can install. Maybe you really like the template that you've created, and I was going to say template, but it is a template on the Amazon service. Maybe you just like installing SQL. Maybe you like installing service packs. That sounds bad, but you know what I mean, right? So you can do it yourself all day, but I'll go back to the conversation I've had many times in this series, so I won't rehash it all here. But this goes back to the big do it yourself or allow Amazon to do it. It's just weigh it all out and see which one works out better. I would say for SQL administration, there's a lot to it. I mean, not just installation and preparing a SQL server, and I'm throwing SQL out there, but I mean all kinds of different database administration. There's a lot to it. Keeping it patched up to date, all those kind of things. So Amazon's like, why do you care about that? Why don't you just go ahead and let us host we'll call it the system administration side of the database, and you just worry about getting your application's data in there in the best possible way. So yes, you can run your own database within an instance, but I would say these probably are pretty compelling offerings for you. So 3 database services that Amazon supports, 1 relational database service, and then 2 NoSQL services. Now, the flyby overview for those of you that are new to the database world, relational database service is like it's been since the 1970s is when they first created the first relational database, and that has been kind of where SQL came from. SQL is not a Microsoft product. It is a language of querying a database, and relational databases, all the tables in a database relate to each other through certain keys. They link together, and there's very specific rules of how that works. Well, a lot of our modern world has started gravitating towards NoSQL, and I don't want to lean anyone one way or the other. It's a big political, like, it's almost like Apple and Windows. When you have somebody who likes relational databases, they're like, you NoSQL junkies, you have no form to your, but in, the Apple guys would be the NoSQL guys being like, yeah, well, Amazon uses it and Google uses it. So NoSQL is a whole lot, it's just Google it. I mean, the fact that they even called it NoSQL is a statement in itself. It is think of it as just an unstructured, I guess the best way I can call it is like a dirty database. It's like instead of everything relating together on these specific rules, it's like, yeah, so here's this table. Throw whatever data you want at it. You can link it together with other tables however you want. It's like a database without rules. But the beauty of having these databases without rules is that they can operate a lot faster than a lot of the relational databases because it doesn't have the rules to follow. But I will say NoSQL, unless you're really careful, can lead to data corruption and bad things, because when you take off the rules, things can get broken. So relational database, these are the traditional ones we always hear about. MySQL being a free version, if you will, a license-free version. Oracle and SQL Server being fully licensed servers. So let me just take you to this. So I'm going to drop from the AWS Management Console into the Relational Database Service. And you'll see when I get there, I've got nothing right now. I can click on Launch a Database Instance. And there's my option. So there's MySQL at the top, and then we've got the Oracle flavors, and then the SQL Server flavors. So let's just say I'm going to run SQL Server Standard Edition. So I click on that. And if you've ever installed SQL Server, Microsoft SQL Server before, imagine the install wizard being this simple. It takes a long time. So it says, well, what's your license? Do you have your own SQL licenses, or are you going to use the license included? And there are, actually I brought up this tab over here just so you can see the pricing. So at the top, just Google RDS pricing, Amazon RDS pricing, and you'll see MySQL, Oracle, and SQL Server. So you can drop down and say, okay, well, with the license included service model, you don't have to purchase any extra licensing. So these are the flavors of SQL, so Express, Web, and Standard. So I'll say, well, I'll use Standard. Now, there is a flavor of SQL called SQL Enterprise, but that is a bring your own license version only on Amazon. So it's kind of like if you have a license, you would use that. They don't have a billing for that yet. Now, I'll say everything with yet because things are always developing. So notice if I use SQL Standard, just compare the two. So SQL Express is Microsoft's free SQL version. You can see a small database is 11 cents an hour, whereas a standard for the standard edition, same instance type, is 65 cents an hour because it's including the licensing fees for that. Now, when you come here, and I'm setting up SQL Standard, you can choose, do you have BYOL, bring your own license, or do you have the license included? So there is different billing models for that. So we'll say license included, SQL Server, 2012 or 2008, we'll go with 12. Medium database instance. Now, Amazon currently does not support multi-availability zone deployments for SQL. They do for some of the other database services, and that just means you have database servers in different data centers. Now, again, if you look it up, Amazon's developing this, so you may hit this drop down when you're doing it, and it may say yes, but as of right now, it does not. Also, auto miner version upgrade. So they will put patches on there and set it up for you to automatically receive patch service on your database if you select. I mean, again, this is just kind of do it all for you. What kind of storage do you want? Now, notice it says SQL is not currently supported for scaling storage, meaning you can't start at 200 and then just kind of creeps its way up to 300 gigs, 400 gigs, and so on. So you have to choose your storage based on what you think you're going to grow to, up to a terabyte in size in this case, and you get better IOPS performance for higher storage. You can provision this is just setting up a database, So I've created my instance identifier. It says what's your port number, what availability zone, or do you just want to throw it in one? Hit next. It does automated backups. What do you want to select when these backups happening, when the patches are applied, system maintenance, or do you just want us to figure it out for you? We'll just kind of click next. So what we're doing here, I'm going to click on launch database instance, is boom, immediately now instant launching. This really is, if you think about it, an EC2 instance. It's an AMI image that Amazon has created with just SQL in all the best ways that they could throw at it. So when I go to my instances now, I can see that it's creating my first database instance. Now I can just take all my applications that use that database and point it at that database instance on the port number that you set in there, and voila, we have a SQL server. We just deployed that. So if you compare that to doing it yourself, if you've ever installed Microsoft SQL Server, we'd still be installing the operating system right now. It takes a long time. So it just takes care of it all for you. Now, Yes, I talked. I'm having a weird deja vu. I talked about NoSQL versus SQL, right? I did actually. I had to pause and go back and listen to myself. My brain gets so scrambled sometimes. So, last thing I do want to mention on the database side of thing is what's the difference between SimpleDB and DymoDB. DymoDB, well, let me talk about Simple. This is, the name really gives it all. This is for less than a database size of 10 gigabytes. If you just want a quick, dirty, it's no SQL database to spin up and put stuff in it, feel free. I have a feeling, maybe even by the time you're hearing this, that SimpleDB will be gone. Right now, well, I'll say its claim to fame originally was that it was super fast, faster than RDS, faster than even DymoDB, because it was so small and just tuned for simplicity. And the simpler things are, the faster that they run. But DymoDB has now come along so far that it's faster than SimpleDB and can scale to insane sizes. So people are starting to say, well, why wouldn't, even if I do have a small database, maybe it's going to grow, why don't I just go with DymoDB to begin with? And right now, a lot of people are asking the same question. So I have a feeling that SimpleDB will eventually be gone from the list. DymoDB, same kind of thing. It's a NoSQL database, but it is designed to scale, and it is designed for speed. So it is solid state disk based, meaning we're not using traditional hard drives, which can only go so fast. We're using SSD, solid state disks, which go really fast. And then the scaling for this is so simple. So Amazon really went out of their way. So instead of thinking about, okay, how many servers do I need? Can this one go to the capacity? All those kind of thoughts when you think about databases. All you do is go to the configuration wizard, and it's like, hey, how many requests would you foresee this database getting, per second, per hour, that kind of thing. And you type it in, and Amazon just scales the entire infrastructure for you. Seriously. No, it's just like, you don't have to think about, Amazon has been running their systems on DynamoDB for a long time, so they know how well it performs and how well it scales based on the number of requests. And chances are pretty good you're not going to outdo Amazon in the amount of requests that you're getting there. So trusting their formula for scaling a DynamoDB it makes it really simple. It makes the database side of things very brainless. Well, let's move from databases to APIs, or application programming interfaces. You might remember from the onset of this nugget, I said that all throughout this series, we've been talking about, you can integrate your application using an API and all that. And so I realize that I'm talking to a wide breadth of people, and not everybody here is a developer. So let me first off start off with what on earth is an API? Well, what it is it's a system. When somebody develops a program, typically a software application, they may allow other people to integrate into that application, whether it's send data in or pull data out or both, or use services from that application by publishing an application programming interface. Think of it like Lego blocks. There's a simplistic view of it. I've got infants, so my mind immediately goes to here. You've got these big old Duplo Lego blocks, right? And these developers say, well, here's the little ports that you can take your Lego block, your application, chunk, and snap it in there, so it now integrates into our application. So, and I think the best way is to see some examples. So, for instance, a website pulling sales information from a vendor. So maybe there's a website that sells widgets. Maybe spinning tops, for children that spin really fast, and they have, ones that stay stable for 3 seconds, 5 seconds, all that. But really, all of this stuff and the pricing information, usually $signs on that side, it actually comes from another vendor that has a top selling business. So you can create an API. This vendor could create an API allowing people to integrate and pull pricing information from this top distributor, and they can then put it on their website and write in their code that maybe they add a 5% markup to all the prices that they receive from the distributor. That way, anytime the distributor changes their prices, someone's not caught not updating their website and be like, oh man, I didn't check today that the distributor updated their prices. The API does it for them to where it pulls the prices onto their website and dynamically adjusts those for whoever's buying from this location. Or another one would be accepting online payments through PayPal. A lot of people do this. Maybe you create your own website where you're selling stuff. So whatever stuff you sell, you accept credit card. Well, PayPal has an API engine that allows you to integrate right with them. So when somebody says, I want to add all this stuff to my shopping cart, and they click the checkout button, it now says, okay, go to PayPal. They click the button, which links to PayPal's API, lets them say, okay, I want to use my Visa card for this, charge $50, and then PayPal sends your website all of the payment, payment confirmed, it's gone to your account, so that you now can then say, okay, the order is yours, you can download your software, or I will ship you this product, or whatever stuff that your website does. So that's all behind an API. It's an application-to-application communication method. Now bring it all down right here. Your applications use AWS services through oodles. That would be a lot of APIs. So just about, I would say, I'm saying just about, but I would say every service, but maybe there's one that I just didn't click on or think of right now. Every service on Amazon's website has an API. Even their DNS services. Route 53, right, has an API to where your application, matter of fact, when I talked about this way earlier on in the series, was it way earlier? Maybe a couple nuggets ago? It feels, I don't know. So your application can actually create DNS records on the fly because there's an API allowing that application to integrate right with Route 53. So what you can do if you want to say, well, how do I get started? Just start Googling Amazon's API. Now, I pulled up one right here for Amazon S3. here's the API in S3, which says this is how, for instance, you would get information from S3. Here is the key that you would send, or the string that you would send into our API, into our service. This is actually called the REST API, which is probably the most well-known system in the world. Oh, I lost it. So applications that want to use S3, that want to get items out of S3 using the S3 API, I mean, not served up via web pages, would use these operations. So an example that I could give you is Cloudberry, right? So Cloudberry, probably one of the most famous Amazon third-party vendors, because they were one of the first to create Cloudberry Explorer, which is a application allowing you to link, well, now link into all kinds of things, but originally link into your Amazon S3 account and put stuff there. Now you can see I've got this is my CBT Nuggets drop. When I record these videos, I actually upload them to Amazon S3 so that CBT Nuggets can process them, and that's how you're listening to them right now. So if I wanted to, I could click on New Account, and I would say, okay, well, display name is Jeremy's S3 bucket, and then you'd have the access key and the secret key. Now, what's that? Now remember, earlier on in the series I talked about IAM, where you create your user accounts and assign them privileges. Well, one of the things that you can assign to your user accounts, as a matter of fact, it does it just by itself, is an access key and a secret key. And right up front it says, if you want to use this user account to access the APIs associated with Amazon, you'll need this. I did it again. So you'll need this information in order to do that. So you would put in the API access key and secret key, click OK, and shoop, you're then connected to whatever S3 bucket you want to. But behind the scenes, I mean, that's all. I don't want to say all, like it was a no-brainer, but that's really all Cloudberry did, is they looked at this document, they said, okay, well, looks like to link into an S3 bucket, we're going to have to create GET and POST operations using the RESTful API to allow people to get files from them, to allow people to put files on there, and all of that. So that's the idea behind the AWS API. So understanding the AWS API is just going to start coming to you the more and more that you use it. You're going to start, and it's almost like you go there based on a need. Sometimes explaining the API. I mean, can you imagine creating a CBT Nugget series on exploring the AWS API, where we just start going through lines and lines of code with the API and be like, okay, well, if you wanted to integrate with S3, you could do this, and here's an example of that. I mean, people would probably go, and fall asleep, because it's like you kind of cross that line into that as you need that, and you start just looking at the documentation. You're like, okay, well, they're saying I need to type this and this, so let me type this and this. Okay, bam, and now I can store stuff in S3, or now I can create DNS records, or now I can spin up an EC2 instance, and all those kind of things. So Amazon has also developed API wrappers, which are modules for your programming language to make just to make it even easier. I mean, when you look at the API that Amazon has created, they have their own way of integrating and all that. So they might say, you know what, we want to make it even easier for you. So instead of typing in all this stuff, maybe you're developing an iPhone application that stores pictures from people taking photos using their iPhone in an S3 bucket that they can then download from their home. Well, you can say, from the iOS to send this kind of, this kind of response to S3 to download a picture, or post response to send a picture, or you can use the iOS wrapper, which just says maybe, I don't program for the Apple iPhone, but I would imagine that there would be an object in there that you could just put in place and say, okay, this is my copy to S3 object. So anytime I want to transfer pictures, I'll just call the copy to S3 object wrapper, which behind the scenes types in all the necessary code to interface with the Amazon API, which just makes it friendly. So Amazon has gone out and said, we just want to make it friendly no matter what programming language you're using. That you can, you've got a wrapper for it that looks like PHP, but really it's typing Amazon API commands behind the scene. The last thing I'll say on the API is it also allows the EC2 instances to authenticate using metadata. Many of you are like, what did he say? Well, here's the beauty. Behind the scenes, this is a behind the scenes API function. I can actually assign permissions to my EC2 instance. right? So I'll say before they had, this is a I'll say fairly new functionality, but before Amazon had it, you would actually have to go into your EC2 instances, and if you wanted this guy to maybe store in an S3 bucket of some sort, you would have to write it in your code to authenticate, and here's the keys and access and what you can get to and all that. But now Amazon has said, you know what, just create a user account in IAM and assign that user to the EC2 instance. And what we'll do is in the metadata, there's actually a folder on that instance. It's kind of hidden behind the scenes like nobody can get to it. But there's a metadata folder where they put the keys to the S3 bucket and even better, they rotate the keys. So every X amount of time, it changes the keys on there so it's even more secure. It doesn't just use static keys that somebody can learn over time, maybe through a brute force attack or something. But they just to make it really easy to integrate your EC2 instances with many of the functionality by using the metadata stored on the instance itself. You can even get to that metadata on the EC2 server if you want to see it. Matter of fact, I just went to the website behind the scenes. Just from that instance, you can open a web browser and go to HTTP, this IP address that's a private, kind of a local IP address, 169.254.169.254 / latest metadata. And you'll have all kinds of stuff in there. Not only, for instance, the secret keys and the keys to get into some of the services, but you can even put your own metadata on there. Yeah, I don't want to get into it because I'm starting to get into the architecture course that we're actually the follow up to this series. We'll get more into that metadata and what's in there. But if you've got some time on your hand and you're like, you know what, I want to go there, go for it, and start looking around. There's a lot in there. So we have seen in here databases, the database offerings that AWS gives you, as well as the API. Officially, we've now said, okay, this is what Amazon uses to integrate your applications with a lot of the Amazon Web Services that are out there. Every single Amazon Web Service has its own API, and they all have their own unique way of interfacing. But if you start really learning those and utilizing them, that's where you gain that loose coupling I talked about earlier on in the series when I talked about all the simple SQS, SNS, loose coupling to where you can really start using all the services and spanning out your application functionality and really harvesting, I guess is the best word that comes to mind, all that AWS has to offer to make your application offering extremely powerful. Well, I hope this has been informative for you, and I'd like to thank you for viewing.